Hello, and welcome to the Buyer's Guide to Consumer Product Design. The consumer products industry faces many unique challenges. Industrial designers and mechanical engineers must work together to bring new products to market with cutting-edge design, market-leading functionality, and low manufacturing costs. The industrial designer needs powerful surfacing tools to create stylish designs with smooth flowing lines and distinctive features. The mechanical engineer needs to take these designs and create products that are easy to manufacture, assemble, and use. To streamline this complex process, you need a design tool that seamlessly combines the needs of both. A concept design may start as a hand-drawn sketch or a model made from clay or foam, so your design tool should work with imported scan data, images from Adobe Photoshop, or even vector line work direct from Adobe Illustrator. Using an image as a guide for curve and surface creation ensures your 3D model is true to the original design. Adding transparency to the image provides additional clarity, so we can concentrate on the imported curves. Making use of symmetry will save time, so we'll start by sketching half the shape of the nozzle. Sketching should be simple and intuitive. This arc simply snaps to the vertices of the imported curves, and additional options are presented right at the cursor, so there's no time wasted searching around the interface. Building complex geometry requires a comprehensive set of surface creation and editing tools. A sweep, for example, creates a surface with a constant cross-section. But you need the flexibility to add extra guide curves to scale the image and to have full control of how the sweep is built, such as keeping the cross-section normal to the direction of airflow. The curves used to build this surface are not long enough, and simply extending the surface will not create the shape we want. This is where you must have the flexibility to edit and modify your existing designs. Extending a curve whilst maintaining the underlying definition of the spline is essential if you want to make your designs as sleek as possible. Using the new extended curve, it should be simple to edit the original definition of the surface without having to delete it and start over. Now that we have the extended surface, we can trim it back to the correct shape. The trim tool should be simple and very visual, so you know exactly what you're going to get. To close this profile, we'll use a boundary surface to create a blend between two or more profiles with full control over the tangency conditions at the edges, ideal for applications like this, where curvature continuity is essential to ensure the quality of your design. Using more curves will give you additional control of the shape, or simply adjust the strength of the curvature using the on-screen handles and the dynamic curvature display. So we've made a good start to the design, but how can we be confident of the quality? Surface evaluation tools are just as important as the surface creation tools. Tangency deviation, draft angle, and undercut detection are important tools to have. But the best way to check quality is to display zebra lines. It's like shining strip lighting on your design. If the lines are smooth, then you know your surfaces are good and will not show up any defects, even to the most discerning eyes. Now, great surfaces start with great curves. Without full control over the quality of your curves, then it's impossible to create good quality surfaces. Building the network of curves required to create the surface for the handle would be tricky without the level of control offered by SOLIDWORKS. Here we are again, using the imported curves as a foundation, copying and trimming them to the correct shape. Concept design and detail design quite often conflict. Using a tool that is built for both enables you to consider manufacturing details early on, like the hole size and location for the power cord, so design changes are reduced further down the line. One often overlooked issue is curve and surface parameterization. Curves of different length can cause unwanted kinks in a surface, and curves with multiple segments are even worse. One way to prevent this is to fit a spline through the curve to make it a single entity, but you need full control over the tolerance, which gives you control over the curvature. A simple composite curve simply won't do. Not all designs can be made from 2D sketches, so it's critical that 3D curves are easy to create and manipulate. A 3D sketch in SOLIDWORKS lets you build your network of curves in one feature to ensure complete flexibility. Let's speed things up a little. Whilst industrial design is all about smooth flowing curves, mechanical design is about precise numbers that a quality control engineer can measure. Using the same spline fitting technology, SOLIDWORKS can create a curvature continuous spline through lines and arcs that is controlled by exact numerical dimensions, bringing true flexibility to all users. 3D curves are often created by projecting two planar profiles, but this is not always possible or easy to visualize. Splitting the screen into two or more viewports and linking them makes it easy to sketch complex geometry. To fine-tune your splines, you need tangency handles and control polygons, and must be able to adjust them in each view at the same time. Curvature continuity to existing curves and surfaces is also of vital importance. Okay, so we've done all the hard work. Now for the fun part. These 3D curves represent a fairly complex shape, so we need a surface that blends the profiles in both directions and gives us fine control over tangency conditions. The boundary surface does just that. As the individual curve segments are added, the preview gives us lots of feedback about the quality of the surface, even before it's created. The mesh indicates that some areas will be stretched and may produce creases in the surface. Connecting points along the curves gives us complete control over surface parameterization. This is absolutely critical if we want to produce good quality surfaces. Tangency is needed on the edges for symmetry. Adjusting the influence and strength of the tangency on screen provides an extra level of control without the need to add more curves. So far, we've looked at precise surface creation. But what about something a little more organic or free-form? SOLIDWORKS can make further modifications to existing surfaces, giving the user full control over its shape and form. Control curves are added to the surface at any location where modification is required. Even the surface boundary can be modified with push-pull simplicity, whilst maintaining tangency or curvature with the surrounding surfaces. To make a change to the shape of the handle, simply grab one or more points on the surface and push or pull. The effects of the change can be seen instantly. Not only does this allow complex edits to surfaces created in SOLIDWORKS, but also to surfaces created in any other tool, which have been imported to form the basis of our design. SOLIDWORKS has other powerful editing tools such as Deform, Indent, and Flex, which enable you to make simple local surface edits or dramatic edits such as bending, twisting, or stretching. All this control is available in SOLIDWORKS without the need for any expensive add-ons. Let's join together the two surface bodies to complete the styling of the design. Extending surfaces must maintain the curvature of the underlying surface and be controlled by length or by a bounding surface. Trimming multiple surfaces can take many steps, but SOLIDWORKS can do as many as you like, all at the same time. Simply select the areas to keep, and the surfaces are trimmed and joined together all in one step. Finally, let's blend the two bodies together using a fillet, either constant radius, variable radius, or by using a face fillet, which allows fillets to jump gaps across unconnected surfaces. So in this case, there was no need to trim the surfaces first. The radius of this fillet can be varied along the length of the edge by following a curve or by keeping the width constant. And of course you can add curvature control. These capabilities are essential to create smooth, flowing designs. The aesthetic design of the product is now complete, so we can start to add manufacturing details. Since the design is all driven from the same model and in the same environment, design changes are fast, predictable, and easy to do. This solid model of the design can now be split into individual components and either saved as an assembly or kept as a multi-body part, allowing you to continue adding features such as lips, grooves, and bosses, whilst ensuring all the parts fit together perfectly. Each part can then be detailed independently and also be used for tooling design. Let's add two more common features to finish the design at high speed. Features like vents and complex hole patterns would take forever to create by hand, and there's no way a library feature can cover all eventualities. That's why SOLIDWORKS makes complex feature creation simple, with dedicated advanced features to make light work of your daily tasks. These features are not just for plastic part design. Many consumer products include sheet metal components as well, where complex features like these are commonplace. Working with customers and suppliers often means importing data and using it in your own designs. Of course, there is no guarantee that this data is of good quality, or if it can be used at all. This trigger design has some surfaces missing and has also appeared in the wrong place. SOLIDWORKS treats a multi-body part just like an assembly, allowing you to use common assembly techniques to position imported data. To fix this up, we have saved the best feature until last. If you've ever tried to build a surface with more than 4 edges, then you know how hard it can be. The fill surface in SOLIDWORKS can take any number of edges and build a smooth surface, maintaining tangency or curvature. This feature alone can save hours on a complex design, so you really can't do without it. And finally, visualization is very important to convey your design ideas to the end user. Having a realistic interactive display lets you try out many different materials and finishes, and react to customer changes quickly before committing to the final design. Creating good quality photorealistic images can be a black art, but not with SOLIDWORKS. Render a scene quickly with preset studios, lighting, and using the same materials, with the power to add extra realism when needed. Selecting the right tool for your design needs is no easy task. This buyer's guide highlights many areas that are important considerations when looking for quick and efficient design of consumer products. We hope you have found it a valuable resource. To find out more information on how SOLIDWORKS can help you overcome your consumer product design challenges, please contact your nearest reseller or request more information on the SOLIDWORKS website.